PLA, PETG, PC, PP, PA, ASA or ABS. If you just got your first 3D printer, but you're totally overwhelmed by which filament to buy, you're exactly where I was when I started. But that's not all, because every filament comes in countless variations. High speed, GF, GF or Ultra. The problem is, if you're buying the wrong one, at best you're just burning money, at worst your printer starts having issues. In this video, I will show you which filament will perfectly print over 90% of your projects, while saving you hundreds of dollars on unnecessary filament purchase. So you never have to guess which filament to use again and can focus entirely on printing. When you're just starting with 3D printing, you want quick wins without technology or material holding you back. But which filament gives you the best balance of easy handling and good results? Imagine you're totally pumped, ready to print your first part, and suddenly your print warps, completely detaches from the build plate or the nozzle clogs. And you're just wondering why it looks so easy for everyone else, but nothing works for you. Pure frustration. But maybe you just bought the wrong filament? There are so many reasons why it makes sense to start with PLA first. PLA is a filament that many manufacturers include as a sample with the printer. PLA is basically the standard, and in my opinion, it's totally underrated. I also had the immediate urge to try all kinds of cool filaments that are even stronger and more robust, but with some of them I just wasted money and time. Because PLA prints on any printer, whether it's cheap or expensive, usually without any problems. You don't need special nozzles or an enclosure. If you don't touch your print bed with greasy fingers and regularly clean it first with soapy water and then with isopropyl alcohol, you won't have any adhesion issues either. And when the model you print needs supports, they are usually super easy to remove with PLA prints without spending forever on post-processing. That saves a lot of time and hassle. Instead of wasting hours optimizing print profiles, with PLA you just get started. A cube, a bracket or a decorative object, and it looks great right away. PLA is extremely easy to print, barely warps and delivers clean results even without an enclosure. And that means for you, you get from the idea to the finished print way faster. And that's just the beginning, because PLA can do way more than just deliver good prints. It also has properties that makes it truly unique compared to all other filaments. Say, you need a vase that perfectly matches your interior decor color scheme. With PLA, that's no problem. You won't find such a huge selection of colors or finishes with any other material, from bright colors to matte finish to metallic looks. Plus, PLA can be made from renewable resources like cornstarch. But those aren't all the advantages. There are probably more variations of PLA than any other filament. There's PLA with wood, stone or real metal particles, and of course glitter or dual color variants with silk finish. But heads up, for some of these you'll need a larger nozzle, and sometimes these PLAs can be a bit tricky to print. That's why my advice: stick with the standard for now until you know your printer better and you're ready to experiment. But don't make the mistake and underestimate PLA's durability. The tensile strength can actually be just as high as technical filaments like ABS. Of course, engineering design is a complex topic, and this is just one of many values. But let's be honest, hardly anyone actually calculates their 3D prints. It's much easier to follow these 3 basic rules and get way more out of PLA. First, always try to align the load parallel to the layer direction and use generous radii instead of sharp corners. Second, you can also increase the perimeter layers in the slicer from the standard 2 to 3 or 4 or more and boost the infill density to at least 30 or 40%. You can also adjust the bottom and top layers accordingly. Your print will take longer, but it will handle way more stress without switching to a different filament. And third, if that's still not enough, you can increase the nozzle temperature a bit and slow down the print speed so the layers bond better. You see, you don't always need special filaments, you get most of the strength from the print settings. But even with the best settings, PLA isn't always the perfect choice for every situation. If your print is going to live in the garden, exposed to sun, heat or rain, you should really think twice about using PLA. It starts getting soft around 120 to 140 degrees Fahrenheit, and that's easily reached in the sun or in enclosed spaces like a parked car in summer. Plus, PLA becomes brittle from UV radiation, and constant moisture or water reduces its lifespan over time. So, if your print will be permanently exposed to sun, heat or weather, you need something else. And this is exactly where PETG comes in. It fills the gaps that PLA leaves open, and here are the 3 key reasons why. First, it can handle temperatures up to about 175 degrees Fahrenheit, which can make the difference between your print deforming in the sun or not during summer. Second, thanks to its different chemical structure, it has better UV and moisture resistance, making it perfect for any prints you want to use outdoors. And third, while it can't handle quite as much maximum load as PLA, it's much tougher and handles impact loads better. This makes it perfect for functional parts that need to take some abuse. With PETG, you can expand your capabilities to exactly what PLA lacks. And with just 2 filaments, you can cover almost all your projects without getting lost in a sea of materials. But watch out! Even though PETG sounds perfect on paper, it has some quirks in real-world printing that might surprise you. And if you hear this crackling while printing and your model has tons of strings and little bumps, you already met PETG's most annoying characteristic. Many plastics absorb moisture from the air, but PETG does this way more than PLA, for example. When heated, the moisture evaporates and print quality visibly suffers. So for PETG, you absolutely need a way to store the filament dry. I just use these gallon-sized cereal containers and add desiccant packs, which you can even recharge in the microwave. PLA also benefits from dry storage, but in my experience it takes much longer for quality to degrade with open storage. And that's what makes it so good as a standard filament. With PETG, your prints might also look a bit messier overall if your settings aren't dialed in. Still, PETG is way easier to print than ABS or ASA. You don't need an enclosed printer like with PLA, and while the particle emissions are higher, they are still way lower than with ABS. So if you pay attention to proper storage and maybe tweak some parameters, you can handle almost any project with PETG where PLA isn't enough. But that brings us to the big question: which filament should you actually buy? There are countless brands and suppliers. Plus, manufacturers are getting pretty creative and now offer endless variety. Hyper PLA, PLA Plus or high-speed PETG? You're probably wondering, is there real value here, or is this just a trick to squeeze more money out of you? Especially the ability to print at high speed seems to appeal a lot of customers, since manufacturers keep emphasizing this in their advertising. Makes sense. Who wants to wait forever for prints to finish? In my experience, brands often advertise features that sound good on paper but don't matter much in daily use. High-speed filaments can actually enable higher print speeds, since they contain additives that ensure large amounts of filament can flow through the nozzle even at high speeds. But the real question is whether your printer can even reach those maximum speeds. Look at this model where the printer is tested for maximum speed. Each layer is printed slightly faster to test the maximum possible speed. In the end, it reaches up to 476 mm per second, which isn't even the promised maximum speed of some high-speed filaments. And still the print fails, because it's not the filament or the printer's mechanics, but the nozzle that is the bottleneck. Every nozzle has a physics-limited maximum volumetric flow rate, basically the volume of filament that can be pushed through the nozzle per second. For a standard 0.4 mm nozzle, this limit is somewhere between 20 to 25 cubic millimeters per second. For my test model, I would need a nozzle that can melt up to about 50 cubic millimeters per second of filament. And since most standard printers don't have this, high-speed filament won't help you much when you're starting out. Many so-called innovations are really just new packaging or minimal recipe changes. Most specialty and high-speed filaments don't bring real value when you're starting out, in my opinion. So what should you really look for? Which manufacturers consistently deliver good results without wasting your money? My tip: stick with known brands, look for deals, but don't try to save every last penny. Brands like Isan, Sunlu or Polymaker are affordable and reliable. I've also successfully used house brands from major suppliers like 3D Jake. Overall, my experience is that premium manufacturers usually delivers slightly more consistent quality for the money. The filament is cleanly wound, so it doesn't tangle during printing, and most importantly, it has low residual moisture. Especially with PETG, don't cheap out. With some really budget suppliers, I had issues where the filament apparently had residual moisture from production, despite vacuum packaging, so print quality was poor and I had to dry it for hours first. If you have a Bambu Lab printer with AMS or a comparable system, cardboard spools aren't great since they can create dust that causes problems. Some manufacturers glue the edge of the spool to prevent this. Specifically for Bambu Lab printers, I can recommend Bambu Lab's own filament since the integrated chip automatically loads the print settings to your printer. If you buy multiple spools at once, the price is totally reasonable. At the top of the quality ladder for me is still Prusament from Prusa. I never had a roll with a bad quality and the filament winding is absolutely perfect. Unfortunately, the price is a bit higher and shipping takes a few days. If you don't print that much, I don't think it's worth buying no-name cheap filament from big platforms. You might get lucky, but if you just don't, you'll spend tons of time optimizing and still won't get clean results. Don't let marketing terms fool you, just try out what works best for you. And yet, there's one filament that claims to combine the advantages of PLA and PETG and change everything. Bambu Lab's PETG HF promises exactly that. High speed, better print quality and UV resistance. But can it really replace PLA? So check out this video now to find out if PETG HF will be your new all-purpose filament or if you're better off sticking with PLA.